that we're comfortable with it. And then I'm going to kind of look at the stuff that Mr. Fulton was teaching, and anything where I'm like, yeah, we cover that in Math 3, I'm just going to cut it out, and we're just going to do the stuff that I know is beneficial to have learned in Math 2, so that we hopefully don't have as many gaps from Math 2 coming in. Okay, so factoring is what we're reviewing, so if you want to give your notes a title, you can say factoring. And the first type of factoring that we're looking at is greatest common factor. GCF for short, that's what most people call it. And GCF is really important because this is the type of factoring that can show up in any problem ever. So we always want to look for GCF before we look for anything else. So let me give you guys, that one looks kind of intense. Okay, let's start off with this one. We'll say for the first problem, this is going to be example 1. We'll say that we're factoring 12k minus 18. And I'm going to show you a cool trick on the calculator. I learned this year. I've been using these calculators for a long time, 15 years, I don't know. And I learned this year. So if you look at your calculator and you hit the math button, math right here, and you go over to number, so math, yep, math, it's under the green button. Math, and you go over to number. Yep, math, go over to number. It's the second column. And you go down, and I think it's number 9. Yes. Number 9 says greatest common denominator. We're not going to use it for a denominator because we're not dealing with fractions, but it's going to serve our purposes. Did you go down to number 9? Do you have a color calculator? Well, no, you have... Hold on. I have a yellow calculator. You went down to number 9. No, it should. Hold on. Math. Oh, you didn't go over to number. Math, go over to number. How do you click on the GC part? You press enter. You press enter. Yep. Go down to number 9. Press enter. Yeah. Math over number 9, or over to number. Press number 9. What it will do if you look at these two numbers is it will tell you what the greatest common denominator is, or really greatest common factor is. That's what it's doing. It'll tell you what the greatest common factor is between two numbers, which is cool because that helps us with factoring. So if we want to know what the greatest common factor is between 12 and 18, we can type 12, comma 18. The comma is right above the 7. 18. This does not do negatives, so it still requires a little bit of thought, but if you are someone who's not great at multiplication, it's really nice. So greatest common denominator for us, we're going to do it for greatest common factor. Oh, 6. 6 is what's in common between those two numbers. Kind of cool. And then for the variable part of it, we have to be the ones using our brains for that. So the calculator can help us out a little bit, but it doesn't do the problem completely for us. So 12 divided by 6 is 2. We didn't take any k's out, so we're going to keep that. 18 divided by 6 is 3, and that was us factoring, taking out the GCF. That's it. What in the world have we been doing? Okay, let's try another one. So this one we're going to do 45x squared minus 20x. You could probably do this one in your head, but we're going to practice it with the calculator because it's neat. So I'm going to hit the math button. I'm going to go over to number. You can scroll down to 9, but you don't even have to scroll. If you memorize that the step is that it's number 9, you can just hit the number 9 and it will pull it up for you. So this time we're looking for the GCF between 45 and 20. So 45, comma 20. Oh, it's 5. Yeah, I kind of expected that. Okay. Now, with the variables, I have to do that myself. The calculator will not do that for me. So with your variables, it's always the smaller of the exponents. So this has an exponent of 2. What does an exponent, or what does a variable have if there is no exponent? It always has a 1. So an x by itself really has an exponent of 1. And when you're looking at the greatest common factor, you're always going to take out the smaller exponent. So between a 2 and a 1, I'm going to take out the 1. 45 divided by 5 is 9. I had x squared, which means I had 2 of them. I took out 1 of them, so I have 1 left over. 20 divided by 5 is 4. I had an x, I took it out, so I don't need it. So I'm done. Okay, let's try another one. So for this one, I'm going to do 9x to the third plus 30x. Okay. So I'm going to hit the math button, go over to number, press 9, looking for the GCF between 9 and 30. Now, do I have to use this on my calculator? No. It's good if I am rusty on multiplication or if I don't feel like using my brain. So my GCF is 3. And then what is my GCF with my variables? X. X to the 1. I've got a 3 and a 1. Clearly 1 is smaller. So 9 divided by 3 is 3. And then I had 3 x's. X times x times x is how you get x to the third. I took 1 of them out, so I have 2 left over. 30 divided by 3, 10. I had 1x, I took it out, so I'm done. Thank you. Thank you. So what I did is I memorized that it was 9. So I hit math, I went over to number, and I just pressed 9. Yeah. Yeah. Okay. So let's try. Let's do 24x to the 5th minus 18x to the 3rd. Okay, you guys are going to try this one. 24x to the 5th minus 18x to the 3rd. Okay, you good? No questions? Does anyone want to share what they got? Yes.
Okay. So GCF is 6.
Uh-huh. 6, just plain x?
Yes.
No.
Wow.
It would be 6x
To the 3rd.
Does it matter?
It does matter.
How do you know?
So you'll know because inside your parentheses, when you looked in your parentheses, did each of your terms in your parentheses both have x? you still had a GCF. So see how in our parentheses this had an X and this didn't? I don't have a GCF anymore.
Okay.
But if in my parentheses I still have an X for both of them, I still have a GCF.
So if you only have one X on one number,
Then that means that you fixed it. Or if, let's say, this was a 10 and this was a 6, I would still have a GCF. Does that make sense? Okay. So 6x to the third, and then what is left over? 4x squared, okay, minus 3. So at this point, I only have one that has an x left, and then this one doesn't. And that tells me I'm done with the GCF for the x's. And then a 4 and a 3, they don't have anything in common. Does that make sense? Okay. All right, let's try another one. 8x to the fifth minus 15x to the third. 8x to the fifth minus 15x to the third. Okay. Anyone know what the GCF is? Okay, tell me what it is.
It's x to the third time.
X to the third. And then what is left? Minus 15. Perfect. Okay. Do we feel good about those GCFs? Pretty good. Okay, you guys ready for like kind of a crazy one? Okay, let's try it. So this one, now when you start to do GCFs in like actual practice, this doesn't happen very often. But at the very beginning when you're learning GCFs and they're like, let's really see if they know how to do GCFs, then they do this all the time. So they start to give you problems where they have two variables. I'll do X and Y. There's not like terms to combine. It seems like there might be, but this one has an x to the third and that one has an x squared, and since they're different, you can't combine them.
You can only
You-
combine them if they have on the same exponent but different but they can have different coefficients.
Yeah. So we're going to look at the number first, and then we're only going to look at the x's, and we're going to look at the smaller exponent. We're going to take that out. And then and then we're only going to look at the y's. We're going to take the smaller exponent out. And then we're going to do parentheses, and we're going to do our leftovers. You can do it. It's not true. Anybody know what number we're taking out? 5. Okay. Okay, so x squared, that's the smallest exponent for the x's. And y squared, that's the smallest exponent for the y's. So 10 divided by 5 is 2. The y's are completely gone. The x's have one more. So 2x.
Wouldn't it be squared? Because then it'd be like x to the fourth power.
Yeah. So we. Yeah, it was a typo. We're fine. We're fine. Yeah. Minus 25 divided by 5 is 5. The x squared, we already took it out, so that's gone. There were 3, we took out 2, so just 1. Okay. Does it make sense how we thought about it? So there's 3 x's here, there's 2 x's there, so we take out 2.
Why are you moving from that side? Like, why are you starting on the right?
No, I'm looking at both. So between 10 and 25, I took out 5. There's 3 x's here, there's 2 x's there, so I took out 2.
So you're taking out what they both have?
I'm looking between the two of them, I'm taking out the smaller exponent.
So if it was 5 or x to the 5th or x to the 3, you take out 3?
Mm-hmm. And then this was x squared, x to the 3rd, so I take out 2. So that's why there's 2 of each. And then I look here, 10 divided by 5 is 2. I had 2 x's out and 2 y's out. So the 2 y's out mean I'm not going to get to write a y for the first term. There's 3 x's here, and I already took 2 of them out, so there's only 1 left over. So that's it for my first term. Then for my second term, I have 25 divided by 5 gives me the 5. For my x's, I already took 2 out, so the x's are done. I have 3 of the y's. I already took 2 of them out, so I have 1 left over. So between what's in the parentheses and what I write, I should have all of it. Yeah. Okay. GCF feels comfortable. Yeah. Let's try another one like this. Okay. So we're going to do 49 x to the 5th, and, sorry, not n, y to the 3rd, plus 28 x y to the 4th. All right, what number? 7. Okay, and 1x y to the third. Okay. There's going to be an x for one of the terms. Mm-hmm. There's not. Yep. Okay. So for the first term, 7x to the fourth. Okay. 4y. Okay. Yeah. How are your brains feeling? Good. Brains are good. Whew. Okay. Our second type. This is going to be trinomials. These are going to be like the most common trinomials, and we're going to say where a equals 1. We're going to do simple ones today. We'll do the more complicated ones tomorrow. So this is, trinomials are ax squared plus bx plus c. And so if the a equals 1, that means that you have the x squared by itself. So if a is 1, the x squared is by itself. Mm-hmm.
So if the x is by itself, so there's no number.
No number in front of it.
But if it was like 8 equals 4 before.
Mm-hmm. Mm-hmm. So these are going to be the simple ones because we're going to have x squared by itself. Okay. So, and these are the ones that you might actually remember from working with Mr. Fulton because you guys started to figure these out a little bit. So if we have like x squared plus 14x plus 45, and I don't know if he did this x thing. A lot of people organize their information this way for these problems. So we're looking for two numbers that multiply to 45 and add to 14. I have a calculator trick for this as well. So what we're going to do here is let's say that we don't say the numbers if you know them, but let's say that multiplication is something that we are just not good at. Then this is the calculator trick. This is how you can come up with the factors of 45 without doing it in your own brain. You're going to go up here to the y equals button right here. And in y equals, if there's something there, you're going to press clear, which is right by the down arrow. Yep, y equals is right up here. So if I was on the normal screen, I would just press y equals. I'm looking for two numbers that multiply to 45. So what I'm going to type is I'm going to type 45 divided by, and then x is right next to the green button. 45 divided by x. I'm not going to look at the graph for that. I'm going to look at the table for that. So table is blue right over here. X is right by the green button. Right here, right by the green. Mm-hmm. If you hit graph, it's going to show you graph. Table's in blue, so we want to hit second graph. Now, the table is going to give you all the pairs of numbers that multiply to 45. We want to find the pair that adds to 14. So graph is right up here. So second graph. So 1 and 45 adds to 46. The second is above the green. That's if you graph it, that's okay. Just go back and hit second graph.
You're looking for numbers
that yeah, so I'm going to ignore the decimals. So 1 and 45, that adds to 46. I'm going to ignore that. Ignore that because it's a decimal. 3 and 15 adds to 18. Ignore that. Ignore the decimal. 5 and 9, those add to 14. I never have to multiply the numbers because all of them multiply to 45. That's what I programmed into the calculator when I did this part. So 4 and 9 are the two numbers that work. 5 and 9, thank you. 5 and 9. So I'm going to write x plus 5, x plus 9, and I'm done. Let's go ahead and clear our calculators. To clear the calculators, we're going to do second, and then plus, and then 7, 1, 2. That's just going to take whatever my students and other classes have done. It's going to clear it away and put you guys back into default settings. And then second, blue button, second plus 7, 1, 2. And then if your table was in a weird spot, or if anything else was programmed into the graph or anything else, it just puts it back to normal. Yeah. Okay, let's try another one. All right, so this one, we're going to do w squared minus 15w plus 26. So we're looking for two numbers that multiply to 26 and add to negative 15. So I would go to my y equals screen. I would do 26 divided by x. 26 divided by x. And then I would do second graph. Second graph. Now, if I'm looking for numbers that add to a negative 15, these are all going to add to positives. So I'm going to press the up arrow to go in the negative direction. Yep. So w squared minus 15w plus 26. I'm looking for numbers that multiply to 26 but add to a negative 15. And what would the numbers be? Negative 13, negative 2. Does it matter what order you put your parentheses in? Yeah, it doesn't matter. Like when we did the w equals 13, w equals 2, that stuff. That is if you're solving. If there's an equal sign in the problem and the instructions say use factoring to solve or solve this quadratic. We are just factoring, there's no equal sign. Yep, good question. Yep. Okay. Let's try another one. C squared plus 2c minus 48. Now be careful with this one because we're multiplying to a negative. So if we use the calculator, we have to include that negative. So look for two numbers that multiply to a negative 48 that add to a positive 2. So if I use the calculator for this one, I would do negative 48 divided by x. Zero times nothing is negative 48. There's nothing you could multiply by 0 to get 48. Did you use this for your negative? This right here?
Yeah.
This is a minus. This is a negative. Yeah, what are the numbers? because those would multiply to negative 48, but they wouldn't add to the right number. Yeah. Has anybody found the numbers? It's a great question. Let's think about it. Does that make sense? Mm-hmm.
Wouldn't it be like -2 or?
Mm-hmm. So that's the thing you have to be careful of with your signs, is to watch out. Okay, so our parentheses are going to be C minus 6, C plus 8. Okay, let's try another one. N squared minus n minus 72. So we are trying to multiply to negative 72 and add to what number? 1. We are close. Negative 1. Ish? Not quite. Okay. Okay.
It'd be a positive 8, -9. It would be -1 if you have a -1.
So when you put that on the calculator, it doesn't matter which one you divide, so can you just take the one
Has to be the number on the end. Mm-hmm. Good question. Okay, so the two numbers we said were negative 9 and 8, right? So n minus 9, n plus 8. Okay, I'm going to throw you a curveball. You guys ready?
Yeah.
Woo! You're making this look too easy, so.
Where's too small?
2k squared minus 16k minus 40. You're like, but Miss Rice, you said there was going to be no a value. There clearly is an a value here. What's happening? Can you tell?
tricking us.
Oh, you have to factor.
You have to what type of factor?
Greatest common.
You have to greatest common factor first. And then you can do the other one. So this is a combination of the two. Okay, so what's the GCF? 2. Let's take out the 2 first. So I'm going to take out a GCF of 2. And what's left over?
A to the second power minus 8k minus 1.
Okay, so the very first thing you had to do is take out the GCF. Now does it look like a trinomial where the a value is 1? Yes. So now you can say what multiplies to negative 20 adds to negative 8. So this is what I meant when I said that every single problem can have a GCF. You could do a GCF first and then not be done and still have to do something else. Does that make sense? Okay.
It is 2 parentheses k minus 1. Yeah, I'm giving you the answer.
Did you guys figure out the numbers?
Yes.
What are they?
It's negative 10 and positive 2.
Okay. So we're going to say GCF of 2. We can't forget that. And then K minus 10. K plus 2.
I would think you have to.
Okay, what was like all math teachers have the same rule?
Okay, here's your next problem.
Not our We're talking about like 10%. We ain't talking about
Is that 2 or 7?
It's a Z. A lot of math teachers cross their Z's so they don't look like 2's. So 5Z squared minus 25Z plus 30. Mm-hmm. What is the first step?
You have to take out your 5.
Take out your 5. And what do you have left over?
Z squared minus 5z plus 6. Miss Rice, when Caleb comes back and I get him back.
Mm-hmm. So what are the two numbers?
It's
Negative 2,
negative
negative 3.
6 and 1.
Ooh.
Oh, wait, it's 5. Never mind.
Somebody X is negative 2, negative 3.
Wait, but it feel okay. So this is actually a common one for students to get wrong. Negative 6 and 1 does give you negative 5. Does it give you negative 6 or positive 6? Yeah. Okay. See how that's an easy mistake to make though. It doesn't multiply to the right number. So, well, it adds to the correct number and it multiplies to 6, but it doesn't multiply to positive 6. It multiplies to negative 6. Yeah. So what should the actual numbers be?
Negative 2, negative 3.
Negative 3, or yeah, negative 2 and negative 3. Okay, so we should have 5, z minus 2, z minus 3. Okay. There's the homework problems. No, because you have two negative numbers, like 2 negatives sitting there and 3 negatives sitting there, and altogether you'd have 5 negatives sitting there. Yes, do not do these on your notes. Do these on a separate sheet because you're going to keep your notes. You're never going to turn your notes in. These should be done on a separate sheet. This is the same way we learned in Math 3.